Have you ever asked yourself if the red you see is the same red I see? It sounds like a silly philosophical question, but neuroscientists and physicists now know it's one of the most important questions about reality, because the answer is mind-blowing. We have no way of knowing. The dress debate of 2015 was scientific proof that two people can look at the exact same object and see entirely different colors. Today, we're going to explore why your brain creates color from scratch and how that changes everything we thought we knew about perception. The philosophical question that science can answer. Have you ever looked at a sunset with friends and wondered if they see the exact same colors you do? That orange-pink glow spreading across the sky might look completely different through someone else's eyes. This question has fascinated humans for thousands of years. Ancient Greek philosophers like Aristotle pondered whether we could ever truly know if others experience colors as we do. What was once purely philosophical now has scientific dimensions. Modern neuroscience, cognitive psychology, and physics have given us remarkable insights into how color perception works. And what they found challenges everything we thought we knew about the world around us. Last summer, I was showing my nephew a rainbow after a storm. He pointed to a section and called it green, while I saw it as blue-green. It wasn't a disagreement about words. We were having fundamentally different visual experiences of the same phenomenon. This everyday moment captures the essence of our color perception dilemma. Most of us go through life assuming colors are fixed, objective properties of objects. The grass is green. The sky is blue. That stop sign is red. These feel like simple facts about the physical world. We act as if colors exist independently of us, just waiting to be seen. This common sense view turns out to be completely wrong. The counterintuitive truth is that colors don't actually exist in objects themselves. They aren't physical properties like weight, shape, or size. Instead, color is something your brain creates. It's more like an interpretation than a discovery. This is scientific fact based on what we now know about physics, biology, and neuroscience. Think about a red apple sitting on your kitchen counter. What makes it red? The conventional answer is that the apple contains something, a pigment or material, that is inherently red. But that's not how color works. Apple has physical properties that cause it to absorb certain wavelengths of light and reflect others. Specifically, it absorbs most wavelengths except those in the range we perceive as red. But there's nothing inherently red about those wavelengths either. They're just electromagnetic radiation with particular frequencies. The redness happens in your brain. Your visual system detects these wavelengths and transforms them into the experience of color through an incredibly complex process. Your brain creates a sensation of red based on the patterns of light hitting your retina, your past experiences, the surrounding colors, and even your expectations. Consider this. If no conscious beings existed to perceive it, would a rose still be red? It would still reflect the same wavelengths of light, but without a brain to interpret those wavelengths as red, the quality of redness wouldn't exist. Color is a feature of perception. Science strongly suggests that the color red you see is different from the red others see. The specific quality of your red experience likely differs from mine in subtle or even dramatic ways. Various lines of evidence point to significant variations in how humans perceive color. Even among people with normal color vision, there are measurable differences in our eye structures that influence color perception. The ratio and sensitivity of different types of color receptors in our retinas vary from person to person. Some people have receptors with slightly shifted sensitivity to different wavelengths. These physical differences inevitably lead to variations in color experience. There's also strong evidence from people with atypical color vision. About 8% of men and 0.5% of women have some form of color blindness, where they struggle to distinguish between certain colors that look clearly different to others. Even more fascinating are people with tetrachromacy, mostly women who have 4 types of color receptors instead of the usual 3. Research suggests they may see millions of color distinctions invisible to the rest of us. Our brains also process color information differently based on our experiences, cultural background, and the languages we speak. Russian has separate basic terms for light blue goluboy and dark blue sini, while English uses modifiers for a single blue category. Research shows Russian speakers actually perceive these as more distinct categories than English speakers do. Your cultural and linguistic background literally shapes how you see color. The science of color perception reveals something profound. We each live in our own perceptual worlds. When you and I look at that sunset, we're having related but distinct experiences. We can agree on the names of colors and communicate about them effectively, but the inner experience, what philosophers call qualia, is unique to each person. To understand why color perception works this way, we need to look more closely at what's happening when light hits objects around us. The physics of light reveals why color isn't a fixed property, but a relationship between objects, light, and perceiving minds. When we understand the physics behind color, we begin to see why our perception of the world is both remarkably accurate in some ways and profoundly subjective in others.